Okay.
Today we are going to discuss about the chapter rational numbers. Before going to discuss about the rational numbers, let us have a brief recap about the various number systems you already studied. The first one, which is the natural numbers, and you know that the natural numbers are denoted by the letter n. And what are natural numbers? The counting numbers are called the natural numbers, and it starts from 1, 2, 3 and up to so on. What is the smallest natural number? 1 is the smallest natural number and there is no largest natural number. The next number system is whole numbers, and the whole numbers are denoted by the letter W. If you add 0 to the natural numbers, we will get the whole numbers. So the whole numbers will start from 0, 1, 2, 3 up to so on. What is the smallest whole number? 0 is the smallest whole number and there is no largest whole number. And after that the next number system is integers, and it is denoted by the letter I or Z. What are integers? If you add negative numbers to the whole numbers, we will get integers. And so 0, 1, 2, 3 and here -1, -2. These are the integers. And after that the next number system is rational numbers. That one we are going to discuss in this chapter. Okay. What are rational numbers? Rational numbers is nothing but if you consider any two integers, let us consider two integers 1 and 2. Here if you consider two integers, you have to write these integers in the form of the fraction. This one you can write it as 1 by 2 or you can write it as 2 by 1. Right? Here, so how do you define the rational numbers? You have to consider two integers. Let us consider those integers as p and q, and you have to write those integers in the form of p by q, where p and q are integers. And here one more condition will be there, which is the denominator should not be equal to 0. If the denominator is equal to 0, what will happen? Let us consider two integers 2 and 0. Here this one you can write in the form of the fraction as 0 by 2 or you can write it as 2 by 0. Here you can observe that the value of 0 by 2 is 0, which is a rational number. Here you can observe that the value of 2 by 0 is undefined. If the denominator is equal to 0, we cannot define that value. So here by defining the rational numbers, you have to consider two integers, and if you write those integers in the form of the fraction and the denominator is not equal to 0, those numbers we call it as an rational numbers. So what are rational numbers? If you consider any two integers, if you write those integers in the form of the fraction and if the denominator is not equal to 0, those numbers we call it as an rational numbers. Now we will discuss about the various operations on rational numbers. And in this we are going to discuss about various properties. The first one is the closure property. Here, and the second one is commutative property. And the third one is associative property. And the next one is role of 0. And the next property is role of 1. And the next one is distributive property. We are going to discuss all these properties under rational numbers. The first one is closure property, and we are going to discuss the closure property under addition, subtraction, multiplication and division. Now here let us discuss the first property, which is closure property. Here we are going to discuss about the closure property under addition, what the closure property says under addition. Here, if you consider any two numbers, since we are going to discuss about the rational numbers, consider two rational numbers. If you consider any two rational numbers, if you add those rational numbers, the result should always be a rational number. Then we can say that the closure property holds good under addition. Let us consider one example, 1 by 2 and 3 by 2. Now, if you add these numbers, let us add these numbers 1 by 2 and 3 by 2. Here, since the denominator is same, you can take it off and you have to add the numerators. What? You will get 4 by 2. After cancellation, you will get 2. Here this 2 you can write it as 2 by 1. Here you can observe that we consider two rational numbers, and if you add two rational numbers, you are getting the result is also a rational number. So here we can say that the closure property holds good under addition. That means if you consider any two rational numbers A and B, what the closure property under addition says, here the A plus B must be belongs to Q. Here this symbol is nothing but belongs. And you know that the rational numbers are denoted by the letter Q. So here what the closure property under addition says, if you consider two rational numbers, if you add those two rational numbers, you are getting the result is also a rational number. So we can say that the closure property holds good under addition in case of the rational number. Next one, we are going to discuss about the subtraction. Closure property under subtraction. Here, if you consider two rational numbers, if you subtract those two rational numbers, you have to get the result is also a rational number. Now consider these two rational numbers, just subtract these two rational numbers. Here, after subtracting these two rational numbers, what you will get here? Minus 3. You know that what is the value of minus 3 plus 1? Here, 1 minus 3 is there. So what is the value of minus 3 and plus 1, which is minus 2 by 2. After cancellation, you are getting as minus 1. You know that minus 1 is a rational number. So here, if you consider two rational numbers, if you subtract those two rational numbers, you are getting the result is also a rational number. This one belongs to the rational number. So the closure property holds good under subtraction. How do you define? If you consider any two rational numbers, let us consider two rational numbers A and B. Then what this statement says, A minus B is also belongs to Q. So we can say that the closure property holds good under subtraction. Now see under multiplication. Here what it states, if you consider any two rational numbers and if you multiply those two rational numbers, you have to get the result is also a rational number. Here consider two rational numbers 1 by 2 and 3 by 2. Here if you multiply those two rational numbers, here how do you multiply? Just you have to multiply the numerators. What you will get 1 into 3, which is 3, and you have to multiply the denominators, which is 2 into 2, which is 4. You know that it is a rational number since 3 and 4 are integers and the denominator is not equal to 0. We can say that 3 by 4 is a rational number. So here if you consider two rational numbers, if you multiply those rational numbers, you are getting the result is also a rational number. So we can say that the closure property holds good under multiplication. So how do you define? Let us consider two rational numbers A and B. Then what it states, A into B is also belongs to a rational number. That means if you consider two rational numbers, if you multiply those rational numbers, you are getting the result is also a rational number. So we can state that the closure property holds good under multiplication. Now let us consider under division. So here what it states the same. If you consider any two rational numbers, if you divide those rational numbers, you have to get the result is also a rational number. Now what we have to do it here, we have to divide these two rational numbers. So how do you divide two rational numbers? You can write it as 1 by 2. If you keep multiplication in place of division, just you have to interchange these places. You can write 3 by 2 as 2 by 3. Now you can multiply the numerators. What is the value of 1 into 2? 2. And what is the value of 2 into 3? Which is 6. So after cancellation, what you get 2 ones 2 and 2 3 is 6. And you can observe that 1 by 3 is a rational number. So here from this what we can conclude here, if you consider any two rational numbers, if you divide those rational numbers, you are getting the result is also a rational number. So here let us consider one more example here, 0 and 1. Here you can observe that here 0 is a rational number and 1 is also a rational number. If you divide 0 divided by 1, what is the value of 0 by 1? You know that the value of 0 by 1 is 0. Now let us divide in the reverse process 1 divided by 0. As already we stated, 1 divided by 0 is undefined. So closure property holds good under division, but except for one condition, that the denominator should not be equal to 0. This is the closure property. So what the closure property says, if you consider any two rational numbers, if you add, if you subtract, if you divide and if you multiply, the result should always be equal to the rational number. The next property is commutative property. The same we are going to discuss this commutative property under addition, subtraction, multiplication and division. So let us see first under addition. Here what the commutative property says. Here the commutative property states that if you consider any two rational numbers and if you change the order, let us change this order. Here we have written 1 plus 2, write here as 2 plus 1. Here after changing the order you have to get the same result. Then we can say that the commutative property holds good under addition. Since we are doing the operation here addition, we are seeing about the addition here. Let us consider two rational numbers 1 by 2 and 3 by 2 here. Now if you add these rational numbers 1 by 2 plus 3 by 2. Here what we are getting here the denominator as 2 and here you will get 1 plus 3 which is 4 by 2 which is 2. You know that it is a rational number. Now what the commutative property says, if you change the order you have to get the same result. Now change this order. Here we add 1 by 2 plus 3 by 2. Now add 3 by 2 plus 1 by 2. Just we are changing the order. After changing the order, what is the result we are getting? Yes, 3 plus 1 which is 4 by 2 which is equal to 2. Here you can observe that the value of 1 by 2 plus 3 by 2 which is 2, and after changing the order which is 3 by 2 plus 1 by 2 you are getting the same result which is 2. From this you can conclude that 1 by 2 plus 3 by 2 is equal to 3 by 2 plus 1 by 2. Right? Here that means if you consider any two rational numbers, if you add those two rational numbers after changing the order, we are getting the result is also the same. So we can say that the commutative property holds good under addition. Now how do you define? If you consider any two rational numbers a and b, now what it states, a plus b must be equal to b plus c. Then we can say that the commutative property holds good under addition. Now see under subtraction. The same, just we are doing under the operation subtraction. Let us consider the same example here. Consider 1 and 2. Here, what we are doing here, we are subtracting the numbers 1 minus 2 and what this property says, after changing the order, you have to get the same result. Now change this order. 1 minus 2 must be equal to 2 minus 1. Is it possible here? What is the value of 1 minus 2? You know that the value of 1 minus 2 is minus 1. And what is the value of 2 minus 1? Which is 1. You know that minus 1 is not equal to 1. So, from this what we can conclude here, if you consider any two rational numbers, if you subtract those rational numbers after changing the order, you are not getting the result as same. So, we can say that the commutative property does not hold under subtraction. So, here, if you consider any two rational numbers A and B, A minus B must not be equal to B minus A. It is not possible for all the cases. So we can say that commutative property does not hold. It does not hold under subtraction. The next one is commutative property under multiplication. The same, if you consider any two rational numbers, let us consider two rational numbers 1 by 2 and 3 by 2. If you multiply those rational numbers and if you change the order, you have to get the same result. Let us solve it. Consider LHS part. What is the LHS here? 1 by 2 into 3 by 2. After solving, what you are getting here? 1 into 3, which is 3. And 2 into 2, which is 4. Now consider RHS, right hand side. What you are getting here? 3 by 2 into 1 by 2. What is the value of 3 into 1, which is 3? And what is the value of 2 into 2, which is 4? From this you can conclude that here, after multiplying these two rational numbers, you are getting the result as 3 by 4. And after changing the order, 3 by 2 into 1 by 2, you are getting the same result. So from this we can conclude that LHS is equal to RHS, which is 1 by 2 into 3 by 2 is equal to 3 by 2 into 1 by 2. From this, we can say that the commutative property holds good under multiplication in rational numbers. How do you write? If you consider any two rational numbers, then if you multiply those rational numbers and if you change the order, you are getting the result as same. So, from this we can conclude that the commutative property holds good under multiplication. Now see under division. So what division says, let us consider the same numbers 1 by 2 divided by 3 by 2. So what is this property says, if you change the order, you have to get the same result. Let us solve it whether this condition holds or not, this equation holds or not. Consider LHS and the RHS part. What is the value of LHS here? 1 by 2 divided by 3 by 2. Here 1 by 2. In case of division, if you keep multiplication, you have to change this value. You have to write 3 by 2 as 2 by 3. So after solving, what you are getting here? 1 into 2, which is 2. 2 into 3, which is 6. And after solving, what you are getting here? 2 ones, 2 threes. You are getting as 1 by 3. Now take RHS, which is 3 by 2 divided by 1 by 2. 3 by 2. In case of division, if you keep multiplication, you have to change this order. You have to write 1 by 2 as 2 by 1. Now, after solving, what you are getting here? 2 into 3, which is 6. And 2 into 1, which is 2. You are getting the result as 3. So, here, if you divide these two numbers, you are getting the result as 1 by 3. And if you are, after changing the order, if you divide these two numbers, you are getting the result as 3. So, here, is 1 by 3 is equal to 3? No, it is not equal. So, from this, what we can observe here, 1 by 2 divided by 3 by 2 is not equal to 3 by 2 divided by 1 by 2. From this, what we can conclude, commutative property does not hold under division under rational numbers. So, if you consider any two rational numbers, if you divide those rational numbers, after changing the order, you are not getting the result as same. So here from this we can conclude that the commutative property does not hold under division. Now the next property is role of 0. What this property says here, role of 0 means if you consider any rational number and if you have to add one number such that you have to get the result as the same number. So what is the number you have to add it here? What is the role of 0 says that if you consider any rational number and if you add those rational number such that you have to get the result as the same number. Let us consider one more. You know that 1 by 2 is a rational number. What this property says, you have to add one number such that after adding that number you have to get the result as the same number. Which number you have to add it here? Clearly you can observe that you can add 0. After adding 0 to any number, you are getting the same number. Here 1 by 2 plus 0 is 1 by 2 and after that 3 plus 0 is always 3. So from this what we can conclude here, if you consider any rational number, what is the role of 0 states here? A plus 0 must be equal to 0 plus a, which is always equal to a. Here same example, consider this example 1 plus 0. You can write 1 plus 0 is equal to 0 plus 1, which is always equal to 1. This one we call it as an additive identity. This 0 we call it as an additive identity. So what is the additive identity? In bits they will ask what is the additive identity. You can say that 0 is the additive identity. What is the role of 0 states here? If you consider any rational number, if you add, you have to add one number such that you have to get the number as the same result. What is that number? 0. That 0 we call it as an additive identity. And after that, role of 1. This role of 1 we can call it as a multiplicative identity. What this one states, let us see. Multiplicative identity. That means if you consider any rational number, if you multiply one number such that you have to get the result as the same number. Consider one more example. 3 by 2 into, you have to get the same number. So what it states here, role of 1, if you consider any rational number, you have to multiply one number such that you have to get the result as the rational number. The same number you have to get. What is that number? Clearly you can observe that the number, such a number is 1. 1 by 2 into 1 is always equal to 1 by 2 and 3 by 2 into 1 is equal to 3 by 2. 1 into 1 is equal to 1. So if you consider any rational number, if you multiply that rational number with 1, you are getting the result as the same number. What we do? So here that 1 we call it as a multiplicative identity. So here, how do you define if you consider any two rational numbers a and b, and if you consider one rational number a, what it states here, a into 1 which is equal to 1 into a, which is always equal to a. So what is the role of 1 or multiplicative identity says, if you consider any rational number, if you multiply that rational number with 1, you have to get the result as the same number. That property we call it as a role of 1. And the next one is associative property. Up to now what we have discussed, closure property. What the closure property says, if you consider any two rational numbers, and if you add or if you subtract and if you multiply, whatever the operation we do, the result must be always equal to the rational number. That we call it as a closure property. And the next one we discuss the role of 0. Role of 0 is nothing but if you consider any rational number, if you add one number such that you have to get the result as also same number. What is that number? 0. And after that we discuss multiplicative identity. What it states, if you consider any rational number, if you multiply one number such that you have to get the result as also same number. What is that number? 1. That we call it as a multiplicative identity. And after that we discuss commutative property. What the commutative property says, if you consider any two rational numbers and if you change the order, you have to get the result is also same. That we call it as a commutative property. The next one is the associative property. For associative property, we need three numbers. Let us consider three numbers, three rational numbers, 1 by 2, 3 by 2 and 5 by 2. You know that all these are rational numbers. What this property says here, 1 by 2 plus 3 by 5 plus 5 by 2 must be equal to 1 by 2 plus 3 by 5 plus 5 by 2. This property we call it as an associative property. If you consider three rational numbers 1 by 2, 3 by 5 and 5 by 2, you know that all these are rational numbers, and after this property we can say that the associative property holds good under rational numbers. What we have to do, first you have to add these two numbers, and after that you are getting one result. That result you have to add 1 by 2. And now let us solve LHS. Here 1 by 2 plus 3 by 5 plus 5 by 2. Here you can observe that what we have done, just we have changed the brackets here. Here what we are doing, we are adding the second and the third number. After getting the result, we are adding to the first number. Here what we are doing, we are adding the first number and the second number. After getting the result, that number we are adding to the third number. Then we have to get the same result. Let us consider this LHS. Here 1 by 2. First you have to solve the numbers under the brackets. Here what is the LCM of 5 and 2? You know that the LCM of 5 and 2, which is 10 here. So what we will get here? Here 5 is there, here 10 is there. Which number you have to multiply such that you will get the result as 10? You know that 5 into 2, which is 10. So you have to multiply this 2 to the numerator. What you will get? 3 into 2, which is 6, plus here. Which number you have to multiply here? You have to multiply with 5, so that you are getting the result as 10. So here multiply this number here. 5 into 5, which is 25. So here 1 by 2 plus, what is the value of 25 plus 6, which is 31 by 10. Here again you have to take the LCM of 2 and 10. What is the LCM of 2 and 10? Which is 10. Here which number you have to multiply here? 5. So here also you have to multiply with 5. 1 into 5, which is 5. Since here the denominator is 10, you have to multiply it with 1. What you are getting here? 31 plus 5, which is 36 by 10. After solving LHS, you are getting the result as 36 by 10. Now take RHS. So here 1 by 2 plus 3 by 5 plus 5 by 2. In LHS what we have done, we added the second number and the third number. After getting the result, you are added the first number. Here what we are doing, we are adding the first number and the second number. After getting the result, you are adding the third number. Now let us add the first and the second number. What we have to do here, we have to take the LCM of 2 and 5. So here, which is 10. Here we have to multiply with 5, so that you will get 2 into 5, which is 10. Since here we are multiplying with 5, in numerator also you have to multiply with 5. 1 into 5, which is 5. Here which number you have to multiply so that you are getting the result as 10? 5 to 10. Right? So here also you have to multiply with 2. You are getting here 6. Now just keep this number as it is, 5 by 2. What is the value of 5 plus 6? which is 11 by 10 plus 5 by 2. Now again take the LCM of 2 and 10. So what you will get here? 10. Here 10 into 1. So we need to multiply here. We will get 11. Which number we have to get here? 2 into 5. Which is, so here also we have to multiply with 5. 5 5 is 25. What is the value of 25 plus 11? Which is 36 by 10. Here you can observe that after in LHS you are getting the result as 36 by 10 and in RHS also you are getting the result as 36 by 10. From this you can write LHS is equal to RHS. This is the associative property under addition. The same you can do for the multiplication, subtraction and the division. Here this one you can do it as the homework here. So here associative property clearly it does not satisfy under subtraction and it satisfy under multiplication and it does not satisfy under division. Later we will discuss